group would like to present presentation 2 blended mode on rate monotonic scheduling. So this is my teammate Chu Yung Binti Hotse and Sharmini Arunan Salam, and myself Fatin Amira. So we have been given set of tasks defined by the following parameters. So this is the table, and we also assume that the task deadline are equal to the period. So we use a preemptive fixed priority scheduling with a rate monotonic priority assignment. So let's see for the first question. So before we go to the first question, we will see on how the calculation happens. So this is the formula of the processor load factor, and this is the condition of task. Is it schedulable or not? So if U is greater than 100%, it is not schedulable. If U is less than 69%, it is schedulable, and if U is less than from this formula, it is schedulable. Otherwise, perform an exact scaling simulation based on a RMS priority assignment to find out. So let's see for the first question and the solution. So this is the calculation happen. So 7/29 plus 1/5 plus 2/10 equal to 64%. This means it is schedulable because if U is less than 69%. So this is RMS priority assignment. So this means it is meet the deadline because the black line means it meet with the deadline. Let's see for the second question. Draw the scheduling sequence of this task set during the first 30 units of times with a preemptive scheduler. So this is the table, and this is the calculation. This is calculation based on the previous formula. So we can see that period value followed by the capacity will be listed down in a set which could be less than 100%. So this is the value of the capacity will be over the value of period, which then will be listed in the table. So this means that the queue of the process will be arranged according to the value of the capacity. The process with list value will be listed down first. In this case, it's T2 first, cause capacity is 1 followed by the T3 with the capacity of 2, and then T1 with the capacity of 7. So let's see for the RMS of the preemptive. So since T2 is execute first, T2 process will execute first followed by T3. After the followed by T1, but because every 5 seconds T2 will be executed, process of T1 will be interrupted and paused and continued with the T2. After done executing, T1 will be continued because T3 will only start to execute every 10 seconds. Since there is a free time, T1 continue to execute till T2 start again and T1 had to pause. It is then followed by T3 and then continued by T1 with the leftover 1 capacity. Since T1 is done executing the whole capacity, it will then not execute anything. Hence, T2 will continue to execute every 5 seconds once and followed by T3, which is 2 times in every 10 seconds. So let's see for the redraw the scheduling with the non-preemptive scheduler. So green is indicate to T1, blue indicate to T2, and yellow indicate to T3. So non-preemptive scheduling is one which can be applied in the circumstances when a process terminates or a process switches from running to the waiting state. In non-preemptive scheduling, once the resources CPU is allocated to the process, the process holds the CPU till it gets terminated or it reaches a waiting state. So on the above diagram, the redraw non-preemptive. On the diagram, we can see that non-preemptive will switch the task on the waiting task. So on the diagram, we can see T1 when wait on waiting state will switch to T2 and continue its process. So thank you for watching videos, and don't forget to subscribe.